React finally launched version 1 of their compiler, and in this video, I'm going to be covering every single concept that you need to know about the compiler, but most importantly, I'm also going to show you the potential problems you may run into. Because if you just go into your project and blindly enable the compiler, you are guaranteed to run into problems. In this video, I'm going to be covering all of those potential issues and show you how you can work around them. Now to get started with this project explaining the compiler, I have two different projects started. You can see I have a compiler folder and a no compiler folder, and they both share the exact same code. We have this app here, that's just the compiler, and this no compiler version is essentially the exact same thing. You can see the code's identical between them. It's just one is running the compiler and the other one isn't. So we can compare and contrast the differences in what the compiler is doing. And if we look at the actual code over here, I created this using Vite, and the only difference you'll see between these two applications is inside this Vite config. You'll notice the one with the compiler has this Babel plugin React compiler, while if I go to the Vite config for the non-compiler version, you can see it does not contain that Babel plugin. And that plugin is essentially how you install and start using the React compiler. So if you have a project that already is built and you want to use the React compiler inside of it, all you need to do is you need to make sure that you npm install this Babel plugin React compiler and add that into wherever your Babel toolchain is. So in the case of Vite, you just throw it in right here inside the React object, and that'll automatically enable the compiler for you. Now, if you're on an older version of React, such as React 18 or React 17, there's a few additional configurations you need to make that I'll cover towards the end of this video when we talk about advanced configuration. But if you're on React 19, this is literally all you need to do to enable the compiler. And the really nice thing is that pretty much every single major toolchain, such as Next.js or Vite, is going to have the ability to do this directly from the command line. So I can just say create Vite at latest, just like that. And you can see once I get my project to name and I select React, you can see that there is a React compiler option for both TypeScript and for JavaScript that I can select. And that's going to automatically install this plugin and set everything up for me. But again, if you don't have that, you can just add this plugin and that's the only thing you need to do. Now also I have both of these applications running, so we can see here's the actual rendered out version of the code for both of these. If we look, essentially I just have a title at the top telling us which side is which. The left is always going to be the compiler, the right is always no compiler. Then I have a label for a name, a label for a number, and then a child that is rendering out that name. Same thing on the no compiler side. Now, if we look back at the code for this particular section, it's relatively straightforward. We have state for the name and age. We have an input here, which is that name variable, and we have an input number for that age as well. And then finally, we have a child component that we're passing the name into, and then we're just rendering that out, and we're logging to the console every single time that the child component renders. Now, the reason I have our code constructed this way is because this shows pretty much the main benefit of the compiler, and the compiler is going to memoize code for you automatically. Normally, in a traditional React application, any time that a parent component re-renders, so whenever this name or age changes, that's going to cause that component as well as all of the children components and all of their children and all of their children all the way down to change to re-render. And this could become performance problems for you because now you have hundreds or thousands of components re-rendering unnecessarily. React introduced a memo function that you can use to try to circumvent this, but implementing this function on your own is quite cumbersome, tedious, and oftentimes you're very error prone and not going to get it 100% correct. This is where the compiler comes in. The biggest thing it does is it automatically memoizes components for you. So for example, if I change only the age property, that means that my name property doesn't actually change, so my child component does not need to re-render. And we can actually see this in action. If I just refresh both these pages, clear out the log, and I change the number on the compiler side, you'll notice I can change this as much as I want, and I'm not getting anything in the logs. Now, if I go to the no compiler version and I try to change the number, you'll notice it's re-rendering my child, and that's because I'm not doing any memoization inside of this, and the compiler is obviously not running, so it's not memoizing that for me. So we can see we're getting those extra re-renders, while if I change the name on the left side, that's the only time it actually re-renders the child for me. Now, if we take a look inside of the DevTools, if you have the React DevTools installed, you're going to see when you open this up and go to the Components tab that any component that is being memoized by the compiler is going to have this nice little memo check next to it saying that it's being automatically memoized. So this is a great way for you to just get an overall view when you enable the compiler in your application, which components are actually being memoized. You should see that all of your components are being memoized, but there may be certain scenarios where the compiler can't actually memoize your component because of how your code is written, and it's going to just error out and not memoize that component. Otherwise, everything should work exactly the same. So if you see this inside your code in the React DevTools, you know that at least your compiler is working. Now, this compiler actually goes a step further though, because it doesn't just prevent components from re-rendering when their props don't change, it also memoizes lots of other values for us. Imagine that we have a function inside of here. We can just call it anything we want. It doesn't even need to do anything, but imagine that this function gets passed down to the child component. So we can see inside of here, it takes in another component, which is just that function which takes in no value and returns void. So you can see we're passing down that function, and let's just say that we're calling it inside of here. It doesn't really matter what this code does, it's just using this test function somewhere. So you can see we're passing that down, and normally inside of React, this function is going to be recreated every time our component re-renders because it's just a brand new function. It gets recreated, it gets passed down to child, which means we now essentially have something that is being recreated on every single render. You would normally need to wrap this in a use callback to prevent things from re-rendering more times than they actually should. But the really nice thing about the compiler is that when you have these types of values, like these functions on their own, or even variables that you create on their own, it'll actually automatically memoize those or wrap them in essentially a use memo or a use callback. So you'll see when we go back into our code and we look at the console, everything still works exactly the same as it did before on this compiler example. When I change my number, you notice it doesn't log anything in my console, even though technically in old versions of React, it would have to recreate this function every single time, pass down a new version, and that would cause even your old memo stuff to break beforehand. Like even if I was manually memoizing this myself, it would still break because of this function. But the compiler is smart enough to know, hey, this function doesn't actually need to update. None of the stuff inside it is changing. So it's just going to keep that function exactly the same and memoize it for me between renders. So it not only memoizes components, but it'll also memoize functions and individual values. To illustrate that even further and kind of start to talk about some of the issues that you may run into, I want to come in here and throw a simple use effect in. And this use effect is going to just log out the name. So we're going to say console log name, but I'm going to be doing it in a little bit of a roundabout way. I'm going to create a variable called data, and I'm just going to set that equal to an object that contains my name. And in here, I'm going to render out the data name. And I want this to only re-render every time my data object changes. Now you'll notice immediately when I do that, I am getting a warning right here, essentially saying, hey, this data object makes a dependency and it's always being updated because I'm not wrapping it in a use memo or anything like that. This comes from ESLint. There's an ESLint plugin called the React Hooks plugin. So we can see here, ESLint plugin React Hooks. It's recommended if you're using the compiler that you have this plugin installed for ESLint. It'll help you with certain React-based rules and hooks. But you'll notice here, essentially what this code is trying to tell me is that on every single re-render, this is a brand new object, which means that my use effect is going to re-render no matter what, whether my name or my age changes. So let's go ahead. We're going to copy this code over to the non-compiler version so we can compare the differences between these, because you may actually run into potential bugs if your code looks like this and then you enable the compiler, because now it's going to act slightly differently. Also, we need to make sure we get rid of this whole test function because we now no longer have that. So let me just remove that from here, and I'll do the exact same on the compiler version, just removing that test function, again, just because we don't have that anymore. And there we go, that cleaned up all that code. So now let's go ahead and actually look at the output of both of these. I'll just refresh both these pages so we have completely blank slates to work with. And when I change my number on the compiler version, you'll notice nothing is being logged out. You can see here that this data name is being recreated every render, but React is smart enough to know, hey, you know what? The name part is the only thing I care about, so I'm going to memoize this and only update it when the name changes. So I can update the age as much as I want, and nothing happens. Now, if I change the name, you can see it's rendering out the child, and it's rendering out my name down here from that use effect. If I go to the non-compiler version though, you can see that changing my age actually causes it to render out that text inside the use effect because again, it's being recreated on every single render. This is something that is the reason why use memo and use callback were pretty much created in the first place to prevent these types of re-rendering issues. So if you just blindly enable the compiler on your application and you have code like this, you're going to run into issues where the code no longer works the same as it did before. Now, this is why they recommend that you install that ESLint plugin, because it's going to give you warnings in your code if you're breaking React's rules. And essentially, the compiler will only work properly if you're following all of React's hook-based rules. So we would need to make sure that we wrap this in our own use memo or use callback, or more realistically, we would just use the name down here and the name right here, and everything else would work exactly the same as before. Now, this type of bug that we had here before where we had that data object is something that's really common in React. So you may already know, hey, I don't have that in my code base. I would never make this mistake. But a very similar mistake that'll cause the same problem that's much more common is a function instead of an object. So I'm just going to paste in the code here. We have a function called log data, which logs out whatever the name is. And then we have a use effect here that depends on that log data. We're doing that part correctly and then calling log data every time it changes. But again, since this log data function is directly inside of my function component, in traditional React before the compiler, it would be recreated every single time, which meant this use effect would render every single time anything changed, whether it was my name, age, or something else unrelated. Now, if we just copy this over to our compiler and non-compiler version, we can again compare the differences. We'll essentially see the exact same thing that we did before. Changing the number on the compiler version does nothing, but changing it on the non-compiler version causes the text to be logged out. And the only way the compiler version logs out text is if I change the name, because essentially the compiler is smart enough to know, hey, this only depends on the name. I'm going to memoize it unless the name changes. Now again, the React Hook plugin comes in and really helps us by telling us that we have a problem right here. But if you're not using that plugin, this is a really easy mistake to make. And when you go to use the compiler in your React code, you'll run into issues where maybe you actually needed this log data to update every single time the age or name changed, and your code depended on that even though it wasn't explicit in how you actually wrote it. So swapping over to the compiler could introduce bugs into your code. Now we've talked about some of the problems with the compiler, so I want to talk about another benefit, and this is a really huge benefit, and that's what happens when you start dealing with context. A lot of people complain about context because it can slow down your application by causing excessive re-renders, but the compiler really helps you with that problem. So let's come in here and we're just going to create a context. It doesn't really matter what the context is. We'll just call it context, just like that. And we'll just say that this context is just an object that contains a name that is a string. We don't want this to be too complicated or anything like that. It's going to be very, very basic. And also it could be null to start out. Now what we're going to do is we're going to wrap some components in that context. So we're going to have our context wrapping these components, and we'll come in here with a value property that just passes in our name. So we have our name as that value, and we're going to have two children. We're going to have child 1 and child 2. And of course, they're not going to actually take the name prop in because we're going to be getting that from our context. So here I'm going to paste that down. We have child 2 and we have child 1 up here. This one doesn't take in any props at all, and we will just make sure that inside of here we use context and pass it in our context. And that is going to give us essentially our name property, just like that. It could be null, I guess, so we'll just force it not to be null. We're just going to tell TypeScript it's not null, which is perfectly fine. And this one in child 2 down here, we're not going to use the name or anything. It's just going to say child 2, and it's not going to take any props. Now, normally inside of a traditional React-based application, when you render out this code and we change our name, which causes all the components in our context to update, that's going to re-render child 1 and child 2, even though child 2 doesn't actually touch our context at all. But with the compiler, it's smart enough to actually see which components use the context and which ones don't, and it'll only re-render the components that it needs to. So in our case, child 1 will re-render, but child 2 will not. So we'll just label this one child 1 just like that. And I'm essentially going to take all this code, get rid of the stuff up here, and I'm going to copy this over into our other version. So here we have our no compiler version, and this is going to be the exact same thing, but for the compiler. So they're both running the exact same code. I just need to import these two things. There we go. And now we have the exact same code running on both. And you'll see exactly what I'm talking about. Let me clear out my logs real quick. And let me try to change, for example, my number. Changing the number doesn't do anything, which is great. If I go to my no compiler version, you can see changing the number already causes things to re-render because I'm not doing any memoization at all. But now as soon as I go into my compiler and I change the name, you'll notice child 1 is the only thing that actually re-renders. And that's because, again, when I look inside my code, child 2 does not depend on the context for the name or anything like that. It just renders on its own in normal function. So it's being memoized by React automatically, while child 1, which does depend on the name, is essentially using that to re-render anytime that name variable changes. And again, if I go to the non-compiler version, you can see both children are re-rendering instead of just one. Now we've talked a lot about what the compiler does and what it doesn't do, but you'll notice there's a lot of gotchas you have to worry about. And on the larger code bases that you may have lots of these problems that with like the use effect and the different things like that, where you may want to not memoize or compile certain components. The really nice thing about the React compiler is they made it super configurable about exactly what you want to happen. By default, the way the compiler is set up, if you just want to opt something out of the compiler completely, you can just add use no memo to the top of that function or component, and that is going to essentially opt that component entirely out of memoization from the compiler, so it's going to pretend like this is not being compiled at all. Now, automatically, just by doing that, I'm going to be opting this component and essentially all of its children out of this memoization, and if I go back over to my code and I take a look at this, you can see here that when I change my number or when I change my name, it's re-rendering both the children, even on that compiler version, because by using use no memo, I'm essentially telling the code, do not compile this function and component. Now, this is great if the majority of your application is compliant with the React hook rules and works fine with the compiler, and you only have a few components you need to opt out. But often cases when you have a really large code base, you're going to be running a lot of code that is not optimized and not meant for the compiler. So you essentially want the opposite. You want to enable memoization only in certain components. So what we can do is we can actually go into the configuration file for where we have that plugin. So it doesn't matter what build tool you're using, wherever that plugin is set up, we can add a bunch of configuration options. And the main configuration option you want to worry about is compilation mode. The compilation mode by default is infer, which essentially means it's going to compile anything that looks like a React component or a React hook. So for example, if you have something that starts with an uppercase letter like compiler like that, that's going to be a React function. Or if you have something like, use whatever, it's going to know that that's also probably a hook that you can compile with the compiler. So it's going to look at those things and infer based on that. Also, if you manually tell something to compile by adding use memo, so the exact opposite of use no memo, that tells the compiler no matter what, memoize this component even if it doesn't meet the standard naming conventions you're used to. The other option that we have is going to be annotation. Annotation is essentially the opposite. By default, the compiler is entirely disabled, and only the functions or files that have use memo are actually going to be memoized. So in our case, the compiler is completely disabled, but we enabled it for this one particular component. So if we go ahead and we take a look at our code to see if this works like we expect, we can refresh. And if I change my number, you'll notice it's still causing things to re-render. That's just because I put this use memo essentially on the wrong file. This is in my no compiler version. If I go over to the compiler version and I add this use memo, we should now see that this is being memoized. So if we come over to my code, give this a quick refresh, and now I go ahead and change my number, you can see that it is no longer causing any of those additional re-renders. So this is a really great way for me to say, okay, memoize only this component and essentially leave everything else completely off by using use memo. And if I get rid of that use memo, you'll now see that if I refresh my page, and I actually change this number, that it's calling that re-render every time, because essentially I'm having to opt into every single component if I want to memoize it or not. This is great for larger code bases where you slowly want to increment maybe even just new code into this memoization way while slowly adding the old code as you go throughout and modify it. Now, the next configuration that I want to talk about is how you actually enable the compiler if you're not using React 19. You can come into here and specify the version, and this is either going to be 17 or 18, depending on if you're React 17 or 18. You specify what that version is, and then you just need to install a single library. This library right here is going to be called React Compiler-Runtime. This library, just get the latest version, and when you install it, it's essentially going to make it so that version 17 and 18 of React are able to hook in and use the compiler essentially as if they were version 19. So if you're on an older version of React, set the version for the plugin, and then just install this one single package, and now you're going to have everything you need to get the compiler up and running. Now, the final little configuration I want to talk about before we jump into some best practices is going to be a logger, and I'm just going to paste in the code here. Essentially, this log event function that we're going to be using in this section, let's just return right here, is going to be taking in a file name, and it's going to be taking in an event. And essentially, this file name is just the name of the file that the compiler is working on, and the event is like, was it successful? Was it an error? And so on. This is coming directly from our logger, so we can come in here with logger, and then we can specify a log event, and this is going to give us a bunch of information. You can get like details and everything that's going on, but in our case, this is really great. For example, if there's an error compiling a specific file, we can see exactly which files are causing errors or which ones are successful. So if we actually take a look at the output here, you can see on this right-hand side, it compiled these 3 different files, well, multiple different files. It's the same file it compiled multiple different times, just because every time I save, it's compiling it multiple different times. But as you can see inside of here, it's compiling 3 different components, because that's why there's 1, 2, 3 components in this file. That's why it's logging out 3 different times here. And I could get that additional information inside of here if I want. This is a great way though, if you just disable this success case and only leave in the error, now you can see in your logs at least any time there was an error when you try to compile something, which can help you find components where the compiler doesn't work because maybe you didn't write your React code perfectly. Now, when it comes to best practices of the compiler, especially for when you're using an older project, is what happens. I have a bunch of, use memos inside my code, or maybe I have use callbacks all over the place. Should I just get rid of these because React essentially handles that case for me? And the answer is no. You want to leave in those use memos and use callbacks that you have in place already, unless those are purely being used for memoizing like a full component, like to make it so that you can wrap your component in a react.memo. In that case, you may be able to get rid of them. But if you're using use memo or use callback for other reasons, such as like performance optimizations or for use effect callbacks, you definitely don't want to get rid of those. Because if you get rid of them, it could cause an unintended side effects, because if the React compiler changes how it compiles things behind the scenes, it may change how it works, which would then change how your entire React application works, which is not what you want. The compiler is just meant to be there as a performance gain. Essentially, it's going to take your React code that doesn't have all these extra memoization steps, and it's going to put memoization in there where it thinks it best fits. Sometimes it's not going to memoize something, sometimes it will memoize something. It's entirely up to what the compiler thinks is best for performance of your application. So if you're depending on these use memos and use callbacks for logic, you do not want to remove them. But if they're purely there for performance gains by preventing re-renders, because that's all the compiler does, then you may be able to safely remove them. But more than likely, if you have hard-coded use memos and use callbacks, you're going to want to keep them in there because they're most likely there for logic reasons or for performance reasons unrelated to re-rendering, such as like calculating really complex large arrays of data. Now, that pretty much covers everything about the React compiler, but if you want to go into some of the more nitty-gritty of some of the advanced customizations for configurations like error handling and some more logger-based stuffs, I'm going to leave a link to this documentation in the description for you. But with that said, thank you very much for watching and have a good day.